some of it ourselves and yada, yada, yada. So
Yada, yada, yada.
yada, yada. All right. I think he's hitting it's not red yet. All right. He's hitting the go live. I'll tell you when we're hot on the YouTube and then going on mute. You're good. Go.
It's not time to go yet. Hold on. So many things. Oh my gosh, here we are. All right. Welcome. Let me go ahead and share this thing over here. Should be good. You should be able to see what's going on. It's class 8, May 10th. Oh crap, 11th. Whatever. It's one of those 2 days. May 10th, 2021. Let's get going. We got clicking going on. I'm teaching from home today, so this will be interesting. I've got dogs. So if the dogs bark, they bark. All right, here we are. We have a break on Wednesday, so that's kind of good. And I did put this note, use it wisely. I don't know if you're like some of us, we get a little passionate about our work and sometimes, take things, kind of lose track of, getting some rest, take care of your mental health and all that good stuff. So hopefully you're doing that. If you're not, reach out to somebody. Yeah, we all need that. So hope you're all doing well. We have at least made it through the first 5 chapters. Hopefully you're following along. Again, first pass, right? I mean, we're going to do this. Well, I mean, if you're going to take the exam, you're going to do this probably 2 or 3 times at least. So that's tough. If you do have questions about any of the content so far, check out the online study group, which I'll give you the URL again here in a minute. Other things, questions that I've seen come in the CISSP mentor mailing list. I know that there are few people who are looking for endorsement. You should get a reply, fairly soon from somebody in our marketing department on how to proceed with that. Some of you have also asked about certificates and CPEs. We can give those out at the end of the course. So once we're all wrapped up here in about 4 more weeks, you can, ping us for those things. If you're looking for credits or a certificate, something like that, we'll provide all that good stuff. Other questions that I've seen come in that mailing list are things like mentorship, a little more one-on-one. You can certainly reach out to us for that. I just was off, earlier today. We do that sort of as we have time. So we'll try to help as much as we can with that stuff. But yeah, so feel free to try that. 134 slides tonight. That's not too bad. We're going to get through this entire chapter 6, all in one night. We have some review. You'll notice some things as we get through tonight's content, some things that we've talked about before. So you'll see some reinforcement of, some common concepts. Housekeeping reminder, we do it every class. This is just the same sort of thing, constructive. I know a lot of us are, really, really good at our jobs and sometimes like to take things a little bit off topic or maybe go deeper into certain things. Really the point that we're trying to cover here is all the content you need to pass the exam. If we want to go deeper on other things, we can do that. But let's stay focused on, getting through all the content for the exam here and take up the other stuff later. This is the URL for the ISSP Mentor Program Study Group. So if you haven't been there, there it is. The first comment you make in that study group will have to be moderated. And after that, we clear the moderation for you so you can have, your conversations freely. So far, it seems like, all the conversations that have been going on there have been respectful. That's nice. If you run into something that seems not respectful, drop us an email and we'll look at it. This is what the page looks like. It's 1,214 members, 92 topics going on there. So that's good stuff. Dad joke. Here it is. It's been a long time, I guess, since we did dad jokes. Normally I do them more often than this. All right, let's go for it. What do you call someone with no body and no nose? Nobody knows. It's cool. It's cool when you do these jokes online because I have no idea if people are laughing, flipping me off on their camera or what. That's what it is. All right, the most secure type of firewall: packet filter firewall, A, stateful firewall, otherwise known as stateful packet inspection firewall, B, circuit level proxy firewall, or application layer proxy firewall. So which one do you think it is? And I will go through, well, there it is, application layer proxy, but why? I think that's important for us to sort of go through. Now, packet filter firewalls, if you remember, they don't maintain state. They're really easy to get to bypass because if I have a SYNAC packet or something, then you might think it's, the second part of a three-way handshake. If I do replies to, or set packets as a reply, a packet filtering firewall will probably interpret that as being part of existing communication and let those things through. So packet filtering firewalls are the least secure on the list here. Stateful packet inspection firewalls, although they're really, really common, they're more secure than packet filtering firewalls, but not as secure as the last two. These are actually in order. The application layer proxy firewall, the reason why that one is the most secure is you can inspect all the traffic all the way up to layer 7 of the OSI model, including individual commands, application functionality. So that's why that one is the most secure. And proxies are more secure too because they essentially act on behalf of the client. What WAN protocol has no error recovery, relying on higher level protocols to provide reliability? Some of these things, like ATM, that was the 53-byte cell, if you remember that. Pretty fast, pretty predictable. Frame relay uses what we call DELCs. It's a layer 2 protocol for wide area networking. Multi-megabit data SMDS. We didn't really cover that too much. And the next .25 actually has a ton of error recovery. So the answer here is B. And model, well, I already said that. Crap, I should have read ahead. It operates at layer 2. So there's just a quick diagram of where frame relay works. IP, IPX, all network layer and above. And then those physical layer, those are really signaling standards for physical media. Right, what is the most secure type of EAP? And if you remember EAP, that's Extensible Authentication Protocol. The first one is EAP TLS, Transport Layer Security. There's EAP TTLS, LEAP, and PEEP. So those are our options. Now, there's one of these that's obviously more secure because it has actually dual authentication. There's client authentication and server authentication. And if you remember, that's this one, and it uses PKI. So that's the reason why, is because you've got dual authentication. There's a lot of overhead. It's more expensive. But we do have to establish a PKI. There's certificates for the client and certificates for the server. That's the dual authentication. And then I just included this, again, as another reference. You saw that reference last week because today's Monday. And that's the biggest reason. So when you look through, these methods, the biggest reason is because the client and server both require certificates, which then allows that multiple or that dual authentication. So that's the strongest, most secure of those. Which endpoint security technique is the most likely to prevent a previously unknown attack from being successful? Signature-based antivirus. Signature-based is based on knowing the attack because that's what goes into the signature. So that one can't be right. B, host intrusion detection systems. Not so much more of an alerting system, not so much of a prevention technique, but depending on if you're using signature-based or anomaly-based, host intrusion detection systems, maybe. Application whitelisting. So application whitelisting, if you remember what that is, it only allows the processes that are specifically permitted to run on a system. So that one seems legit. And the last one's perimeter firewall, sort of not even there. So application whitelisting is your right answer there. Easy peasy. All right, which wireless security protocol is also known as RSN, or Robust Security Network, and implements the full 802.11 standard. AES is part of that 802.11 standard. WEP is not part of the 802.11i standard. That's the bad one. WPA was that kind of halfway in between from the WEP to WPA2, and WPA2 is actually the answer here. That's the full implementation of the 802.11i standard. All right, restricting Bluetooth device discovery relies on the secrecy of what? MAC address, symmetric key, private key, or public key. It's actually the secrecy of the MAC address. And yeah, that's the answer. So anyway, let's move on. This is domain 5, identity and access management. Two separate things, identity management and access management, not IAM altogether. Controlling access and managing identity. This is chapter 6. This is what's changed from the domain refresh. So same exam weight, 13% across. Control physical and logical access to assets hasn't changed. Manage identification and authentication of people, devices, and services. That hasn't changed. Federated identity and third-party service. We're going to come back to that at the end, because what I'd like to do is summarize all of these changes in one last class. There's not enough change really to alter kind of the content here. I think at the end we'll summarize. So you'll have kind of a supplement of the content at the end. Implement and manage authorization mechanisms. That's the same. Manage the identity and access provisioning lifecycle. That's also the same. And then implementing authentication systems, which is sort of sprinkled throughout domain 5 anyway. So not a ton of change, but some few nuanced type changes that we'll include at the end. This is our agenda for today. We'll talk about authentication methods, access control technologies, access control models. Thank God we won't go as far as the models that we went through before, which were really security models, not so much access control models. This isn't a challenging domain. It's not really overly complicated. We'll cover some things that I'm guessing you've probably heard of before. Even if you're not in the information security field, you've heard of things like multi-factor authentication and stuff like that. Page 293. So if you're in the book, that's where we're at. This is some unique terms and definitions we're going to talk about today. These ones are review and these ones are new. So crossover error rate is something that some of us never heard of before. Really, it's used to measure the accuracy of a biometric device. You've got the false reject rate and the false accept rate. Where those two cross in a diagram, that's called the crossover error rate. And that's used for accuracy. And we'll cover that again and show what that looks like. Discretionary access control, we talked about that a while back. Here's our thing about subjects and objects again, the relationship between subjects and objects. Subjects are active, objects are passive. Subjects get clearance, objects get labels, right? So that's how discretionary access control works. Except with discretionary access control, I have discretion. So we'll talk about what that discretion is. That's what we're used to. You see that in Windows systems, Linux systems. So that's the one we're all used to. False accept rate is when a biometric device or system accepts you as being legit, as authenticated, when actually you're not. That's a false accept rate. And the other one is the false reject rate, where you might get rejected if you are a legitimate user. As a security person, we like false reject rates more than we like false accept rates. And like I said, where those two crosses are crossover error rate. Those are going to be important. And we'll have to remember which type is what for the exam, because they may refer to it as specific types. Mandatory access control. This is truly where subjects have clearance and objects have label enforced by the system, very rigid, typically used in government applications. We'll go through a little bit of that again. And then role-based access control, so based on your specific role. Now, a true implementation of role-based access control is not discretionary access control. It's truly, here is the role, these are the requirements or the privileges, the rights, the permissions that you need for that role, and then you're pretty much stuck in that role. But what we see in practice normally is a combination of role-based access control and discretionary access control in like a Windows, Active Directory environment or something. For the exam, separate things, but in reality, we use them together. All right, so authentication methods. Again, we talked about the subject and the object. Here, a subject is authenticating themselves. So the subject doesn't necessarily have to be a person. Either a subject can be a process, it can be a service, it can be anything that requires some authentication, right? We've got that thing called identity, and then we have to prove our identity, and that's where authentication comes into play. So just because somebody professes to be, or a system or process or a service, claims to be something, we still have to authenticate that. That's the assurance piece. Those two things together, we call a credential set. And then the basic authentication methods. These are pretty easy to remember because they're really listed in order of commonality. Something that's the most common authentication method today. That's a PIN number, a password, something like that. That's one that makes us all really happy. Type 2 is something you have. That's really the second most common type of authentication, whether it be a mobile device or mobile phone, whether it be a token, whether it be any number of things. It's just something that you have. And then the something you are is, the biometric piece. There is a fourth type of authentication, which really doesn't play, and officially it's not really a fourth type of authentication, but it is, someplace you are. In reality, there's a whole combination of these things. There's also adaptive, authentication, which is based on a certain set of rules, right? Behaviors came from the browser version that you're using. Those things are all kind of given a score. And then based on that score, if it exceeds, there's more certainty that it is actually you. That's an adaptive authentication, not testable, but it's common, right? But it doesn't fit exactly in one of these three types. For the exam, you'll need to know these three types. So type 1, something we're all using this one all the time, right? Usually it's a password or a PIN. Easiest, weakest, most irritating type of authentication that I think we all have to deal with. I think the average user nowadays, I think last I read, has 76 different user accounts and passwords that they need to remember. So that's why we use, password programs, to keep those things, sort of in order. I was talking to a guy today, and he's saying, well, what do you do with your master password? Like, well, I only have to remember my master password. But another thing that I do master passwords, I do write it down. It's in an envelope, and it's stored in a safety deposit box. In case something were to happen, my wife can still, she's not left in a lurch. But other than that, there's nobody else. I've never shared my password with anybody, and nobody else knows it. But there's that process that she'll need to follow should something happen to me. Password's really, really big deal. Passphrases, it's really just taking, a sentence, a phrase, and using that as your password. The rule of thumb, the biggest factor in making a password strong is making it long. And the reason why is because of the key space required to work through it in a brute force attack, assuming that you didn't just use dictionary words. And we'll get to those different types of password hacking or cracking here in a little bit. But passphrases, longer is stronger, always. Special characters don't work so much, that leet speak used to, but those are part of many dictionaries now, so not all that helpful. Passphrase, long passphrase is the best. One-time passwords change every time. They are super secure, but they're a pain in the butt to manage, because you somehow have to get the password to the person who's authenticating. There are ways to do that with tokens potentially, where you use almost like an RSA, where you use a challenge from the server, you enter the challenge into the token, then it gives you that one-time password. That's sort of an implementation, one-time password. Other one-time passwords that I've seen are, here's the order of passwords, you need to use this order, and that's really a pain in the butt. Right. This is just, how secure is my password? You guys have all probably played with this at some point. I don't know what an undecillion, but that's a long time, to crack that password. Don't type your real password in here. Hopefully that's kind of obvious, but play around with different password combinations till you find like, okay, in this particular case, when you take my password is super strong, exclamation point. We have no numbers here. We only have one special character, unless you consider the space to be a special character, one uppercase, and all of those words are in the dictionary. According to how secure is my password, that's how long it takes to crack it, because it's so long. Take this next one, which is, it's got a 0, couple of special characters, sort of some leet speak, but it's not as long. 2 billion years, still a long time. We talk about work factor. Work factor is how long it takes to bypass something, or how long it takes to maybe crack a password. We want the work factor, how long that is, to be longer than how long the data is valuable. So, if I protected my social security number, my bank account with that password, and it took 2 billion years, by the time you crack it, the data is probably not worth anything anyway. Taking that into account, and password or computers do continue to get faster and faster. So that 2 billion years, I would assume, will get much smaller. And that reminds me, last week I saw IBM in a lab actually made a 2 nanometer CPU, which, if you know, a nanometer is 1 billionth of a meter. It's like super duper teeny. Today, in most cell phones, like I think my iPhone is probably 11 nanometer. And I don't know why I'm thinking this. I think it's because things get really fast, right? Things keep getting smaller and keep getting faster. So 2 nanometer, allegedly, that'll make you might be able to go 4 days before you have to charge your phone. I don't know. Interesting side note. Definitely not testable. What's important here is long and strong. And this is an algorithm that we use to test password strength. Also not testable, but I think it gives you a good idea of what pieces make a strong password, right? If you go through these 18 rules and with more positive than negative, it's really, really darn strong password. But you can program this stuff, so when you're looking through a password, you can judge its strength. This was a publication, and this also won't be testable, but I think it's important to point out, NIST came out with a special publication 800-63B, and anybody can go look at this. But they caused a lot of confusion about passwords. Do I need to change passwords regularly? Because it was a little confusing based on all the other stuff we'd been doing prior. So this was the summary. This was the 2019 password guidelines. 8-character minimum when a human sets it. Now, an 8-character password is not strong. 6-character minimum when set by a system or service. Support at least 64 characters maximum length. All ASCII characters, including space, should be supported. Truncation. The 8-character and 6-character would certainly go against, my advice. At least 10 password attempts before lockout. No complexity requirements. No password expiration period. No password hints. So a password that never expires. If you think about that, I can keep my password as ultra secure as possible, right? Never share it with anybody, but I do have to share it with the person I'm authenticating with. I need to share it with, the cloud service, share it with the bank, share it with school, share it with whatever. So it's fine if I never give up my password. What happens if they get hacked, if they lose that password? And if it's only an 8-character password with no complexity requirements, it's not going to take you very long to find that collision of the hash, right, and get my password. If you're telling me I never need to change that password, it's kind of funky. Whereas at the same time, no SMS for 2-factor authentication. The most common attack against SMS on 2-factor authentication would be, to essentially SIM swap, which would be to get a new SIM for your phone, which you'd know. So anyway, these password requirements, I think, or these password guidelines that came out in 2019, I think were confusing. It went against a lot of the things we're doing. Since then, the dust has settled. Use a long password. We like 14, 16 characters minimum, which, whatever. We're security people though. Other thing about type 1 authentication, the something passwords, we have dynamic passwords. A dynamic password is one that checks on a regular basis. There's two types of dynamic passwords. The most common is probably the synchronous token device. And every time you hear synchronous, it means a clock. There's some kind of clock-based, time-based synchronization between your token and the authentication server. Secure ID is a very common one, or at least it was when the book was written, and it's still around. Basically, you would type your PIN into the RSA, would create that code, and that would be your one-time password. Yeah, these do cost money, so and we don't have to go into Duo and all these authentication types for the exam, but there are lots of other authentication types, limitations to this. The thing to remember about dynamic passwords is a synchronous dynamic password is one that's synchronized with the authentication server. Strong authentication, also called multi-factor authentication, it would be more than one type of authentication. So here we've talked about type 1. If I add another type of authentication to the type 1, or use type 2, type 3, which would be a little bit funky. But if I add something else to type 1, that would make it strong authentication. Strong doesn't mean it's unhackable. Strong just means it's not as weak as just having a password. Other things about password are type 1 authentication and passwords, password hashes and cracking. So you don't want to store the password, the clear text password, in anything, in any database, anywhere. Instead, what you store is the hash, right? So you run the password through a hash, you store the hash. So then if the attacker gets the hash, they don't have the password, right? You can't pass the hash. Well, you can, but not here. You pass the hash through the login, right? To get access, you have to use the password that would have to hash to the same output. So ideally, your hash function is not susceptible to collision. So you'd have a legitimate expectance that two things hash to the same value would be the same password, right? But you never send the password, you send the hash of the password. And we remember how hashing works, the one-way encryption, not reversible. Yeah, so that's how you store passwords. Now, password cracking would be looking for a value that hashes to the same value. So it's either a collision. So we found another password that hashed to the same output, which would be a collision, or we found your password, right? That's the purpose of the password cracking. Now, cracking, brute force cracking would be going through the entire key space. But anyway, that's password hashing and password cracking. And I found this because I remember this. Facebook was storing the hundreds of millions of user passwords in plain text for years. Never do that. That's why you got to what the special characters. And it still happens, occasionally you find, organizations that for some reason they were storing the clear text passwords and not the hash values. Other things about hashes, where on Linux systems, they're stored in a place called etc shadow. So that's the directory on a Linux system. If you've used Linux, you'll know that. Only accessible and readable by root. That's where they're stored on Linux systems. On Windows systems, stored on the domain controller in a account management file or a SAM file. Hashes can be sniffed on networks and read from memory. Sometimes it's a more sophisticated attack. It's more common to go right after the database somewhere. SAM file is locked by while using Windows. There's a tool called FGDump, and that's not necessarily testable. The point of that is just because the SAM file is locked doesn't mean that you can't get it. You can dump the hashes from memory and then take that offline and, run your password cracking tools. And there's a link there if you want to know more. There's lots of ways that you can get a SAM file and get password hashes. That's just one example. The point here is just because it's hashed or stored in a secure database doesn't mean that you can't get those hashes. Yeah, that's the point. Technical review. So this is a pretty good read, and I think I provided the URL at the bottom. This is also not testable, but I think it's very relevant if you want to know more about the where the passwords are stored in Windows systems. The OWF is Microsoft's way of saying one-way function, which is essentially just a hash. But an interesting read. I think if you're struggling, memorizing any of this, then maybe reading this will be, help it make it more applicable and make it sink in more. This is the Keen Enable that I was telling you about before. Now, Keen Enable is an old tool. It's pretty much not supported really anymore. It hasn't many updates for it for a while, but it still works on a lot of different things. You can use it and play around with it and type different things in to see what they hash to, which is sort of fun to play around with. So you can go get that if you want. Do it on your system, I assume, not a work system. Keen Enable does set off, some antivirus and endpoint protection stuff. Keen Enable is fun. It's been one of my favorites for a long time. It's not, it's less functional over time, but it's always been good memories, if anything else. All right, so different types of attacks. So we haven't talked really about attacks. What we've talked about at this point is just sort of those hashes. So let's say you get a hash database, or maybe you're brute forcing from the front end, which is typically not the thing, because you can only go through, depending on what those account lockouts are set, by the admin, maybe 3, 5, 10 invalid logins before you get locked out for some period of time. Sometimes it requires an admin unlock. So usually online password attacks are not the way to go. It's to try to get the hash value and go at it that way. So a dictionary attack is nothing more than just a huge list of words, of dictionary words. And all your computer is going to do in this type of an attack is compare all of these words with, what they hash to what you have. Now, dictionary attack is a little bit different than a rainbow table, because rainbow tables actually store the hash values themselves. But just think of a dictionary attack as just being a word list. It's super fast. It's effective for anybody who's using, dictionary words for passwords. Yeah, and a lot of times, the note there is really true. Depending on the target, if you're going to use a dictionary attack, it's pretty common to tune your dictionary to your target. Yeah, so something to remember about. Well, the thing to remember here is dictionary attacks are using just dictionary files or word lists, and all that word list has is just a list of words, right? And your computer is just going to compare them. There's a link there if you want to look at what a word list looks like, where you can go grab some. Common passwords from 2011 to 2019. This just comes from, this is according to Splash Data. The last year, I think they used a different organization in Wikipedia. Not that Wikipedia is like the end all be all, but this is just examples of what those common passwords were. So password itself, it's been in, number one, number two for 6 years, and then number 4. It's interesting to just see how these evolve. And this is last year's. So password still made top 5. 1, 2, 3, 4, 5, 6. Yeah. There you go. Hopefully you're not using any of those passwords. These passwords would definitely be on a dictionary list. All right, other types of password attacks. So the first attack was the dictionary attack. The second one is a brute force attack. And then the last one really is hybrid attacks. Well, actually not the last one. We have rainbow tables too. I suppose you could call it a hybrid. Brute force attacks is just trying every combination of characters, numbers, Unicode, until you find hash values that start to match. Take a lot of time. Most I think more sophisticated attackers will use what's called a cracking rig, which is just a really, really powerful set of computers. Potentially, we're operating as a cluster, or at least with many CPUs. This is really CPU intense, and it's just dedicated to running. It's optimized and dedicated to running password brute force attacks. Yeah, it's CPU intense. So also using rainbow tables. So a rainbow table is really just pre-computed hash values of all the most possible passwords, or the most common passwords. Some rainbow tables can get really, really, really big, like multi-gigabytes. I've seen some over 100 gigabytes. So rainbow tables are big. You would load those up, obviously not on your laptop. You'd load them up on a rig and use that. So brute force. So the things to remember: dictionary attack, using the word list. Brute force, really not using a word list in the purest sense. It's just going through every value to create, to look for that hash collision or look for that hash match. And the hybrid attacks, really adding different things. So if you look back at this, when I went here, got mix of letters, numbers, character weight for passwords. We've got 80% of the password exists in the dictionary, and then some with simple obfuscation, word and numbers appended. That's this type of an attack. That's why we're testing for that, this hybrid attack, where we append, prepend, change characters and words from dictionaries before hashing. Yeah, this is also where you put hybrid attack would be, using those leet speak characters. That would also be an example of a hybrid attack. So 3 types of attacks: dictionary, brute force, hybrid. These are just tools, and these probably aren't going to be testable, but I think they're, kind of cool if you wanted to play around with these types of things. Brutus is popular, been around for a long time, still around, still works. Rainbow Crack is another tool. This one's obviously very good with rainbow tables, because that's what it was really built for. And there's the URL for that if you wanted to go play with that. This is just example stuff. WFuzz, another password cracking tool. That's what that looks like. That comes as part of Kali Linux. So if you're into red teaming, you've probably been using Kali Linux at one point or using it now. That's one of the tools, just comes built in with Kali. Gain Enable, one of my favorites. John the Ripper, still around. And this is what, where you can go get a copy of that. You can also donate. John the Ripper's been around forever, still really, really popular. DHC Hydra is another tool, and you don't have to memorize these. These are just provided if you want to go, and sometimes people like the hands-on stuff, like so you can use one of these tools and play around and do some hands-on work, or maybe this is part of your job and you're using these tools already. DHC Hydra is, another tool. This is from GitHub. It's where you can go get a copy of that. And you can, updated 14 days ago, 753 commits. So it's still very actively, most of these tools are all really active in terms of their support. Medusa, another password cracking tool, really similar to Hydra. That's what Medusa looks like. Offcrack. So Offcrack was kind of a spin-off from Loftcrack. It kind of kept it free. Rainbow Table, good tool for that. Windows XP. So we're cracking those Windows XP boxes. But even this is actually up to date too. And Loftcrack. Remember Loft Industries, L0PHT Industries. This is where Mudge was. Some history stuff there. It used to be free, but now it's a commercial product. And Mudge isn't part of this anymore. It's just that's where it sort of came from. Aircrack NG. So if you're cracking wireless, usually you use this combination like Kismet, and that kind of, that sort of setup and rig. Where, Kismet would help you find and potentially sniff that network traffic, so you can get those hash values that you can feed into Aircrack NG and do some cracking. That's also supporting January 20 nothing has really changed, from January 25th, 2020 in terms of most Wi-Fi networks. So still very valid. All right, so that's that password hacking, cracking. So one of the things with hash values, if two of the same password will hash the same way, right? So two of the same inputs hash to identical values. That sort of takes away some of our frequency analysis, makes it easier to crack, makes it collisions more common. Salts is one of the things that you can use. Typically, salts are randomized inputs that you add into the hash stream. Yeah, that's what a salt is. And it's meant to make two different values hash, two different inputs hash to different values. It makes password cracking more difficult. It makes rainbow tables basically almost ineffective, because remember, rainbow tables is just a storage of hash values. Well, the hash values don't match passwords anymore, so that makes it sort of ineffective. So salts is a good thing to use to protect passwords. So password management, typically you don't want long and strong. If there was one thing that you could get users to be less resistant to, so you don't want to change your password that often, fine. Can we compromise and maybe just make them really long potentially? These are things from the book. Password history set to remember 24 passwords. The reason why you have a password history is if I had a say a minimum password age of 2 days, and I didn't have a password, and I had a password history of 2, means in 4 days I could go back to the password I was using before. So it just makes it, in this particular case, if the minimum password age is 2 days, and I'm set to remember 24 passwords, you can't basically use the same password again for 48 days. That's why you put the minimum password age and the password history together. The maximum password age, 90 days. So every 90 days, that's the password expiration. Minimum password length, 8 characters. Really, 14 would be good. 16, longer is better. Complexity requirements and store. So those are all from Windows systems, all those variables there. U.S. Department of Defense, Microsoft Community, whatever is the complexity standard, that's what goes into it. If you have to write down your password, see, some people you just can't, no matter what you do, you can't get them to not write down passwords. Like I don't think she's going to be watching. My mother does that. And so the advice for her is if you have to write them down and put them in your purse or put them in your wallet. Put them in something that you'll notice if it's gone. Yeah, something like that. Or just don't write them down. Complex passwords are definitely harder to remember. So we sort of defeat ourselves with that when we make password complexity requirements onerous. They also get in the way of business. We can't forget as security people that a business is in business to make money. Business is not in business to secure information. It's important, but the ultimate purpose of many businesses is to make money. So we have to get out of the way of them making money as much as we can. So that's always the compromise, comes down to things. Type 2. So that was all type 1. That was all password stuff. Type 2 is something you have. Every time you go to the machine, you're using multi-factor authentication. You have something you have, your card, and something your PIN, right? That's multi-factor authentication, probably the most common type of multi-factor authentication. Here, it's just something you have. That's something, the theory is you would be the only person that should have that thing. That in combination, the only person that should know that thing should be a good authentication, or at least a strong authentication. Phones are the most common still today. SMS, and security people like to point out, I think, problems and sort of lots of things. Yes, SMS is hackable. Yes, your token is hackable. Yes, just about, everything made by human beings is hackable. SMS is one of the weakest forms of the something you have piece, meaning, sending a text message to your phone, but it's better than not having, that second factor at all. So, take your, if you get users to agree to that, take that as a victory. You go further. So type 2, something you have. Synchronous dynamic token. So again, that synchronization works a lot like the type 1. Not to get confused, you have to have the token. What we talked about in type 1 was what was given from the token. Here, it's the token itself is the second factor of authentication. Synchronized with the authentication server. FRSecure ID is really common. I think almost everybody now has Google Authenticator. That's also a synchronous dynamic token, synchronized with Google's authentication. And every so often you'll see it flip, right? It'll give a new value. That's the synchronization piece of that dynamic token. There's what Google Authenticator looks like. Asynchronous dynamic tokens, there is no time synchronization at all. Usually it's a challenge and response. So you get a challenge from the authentication server, you type that challenge in the token, you should get a response that you would then respond back to the authentication server. That's the most common implementation of asynchronous dynamic tokens. And that's essentially what it looks like. So you have your RSA, and to make things even more complicated, it's also called secure ID. But you'd get, a challenge back from the server, you type in, send it back, and you'd be authenticated. RSA, this was a while ago, but it's so relevant because, like I said, everything's hackable. So this was back in 2011, and this caused quite a stink because it rendered RSA tokens essentially compromised. So there's a big replacement of all those tokens. If you worked in any large organization that was actually using RSA back then, because it's expensive, you're probably part of getting a new token. Not testable, but kind of cool. Type 3 authentication, this is something you are. So something you know, something you have, something you are. This is the third type, the third and really the last kind of official type for the exam. These are also called biometrics. The something you are is some physical characteristic about you or something derived from a physical characteristic about you is what's used for authentication. There are certain things about human beings that are very unique. Those make for good authentication things. The bad thing about it is if they're stored incorrectly, I can't change them. I can change a password. If you compromise my password, I can change it. If you compromise my token, I get a new one. If you compromise fingerprint, I can't get a new fingerprint. Or if you compromise my iris scan, I can't get a new iris scan. If you compromise facial recognition, I can't get a new face. I mean, I can, but right. So it's really important in implementation of biometrics that you don't store the entire image, that you store what's called the minutia or a mathematical representation of the image, almost like a hash function with passwords. You have the image, you create this mathematical algorithm that this image should only be able to create that number, that whatever, and I can't get it back the other way. So really important with biometrics. But nobody ever takes shortcuts in security, so you don't have to worry about that. It's never going to happen to you or me. Right. All right, biometric fairness, physiological comfort, and safety. These are all going to be part of, definitely be part on the exam. And I've got a summary at the end where I've just got a table that shows the fairness, the psychological comfort, because users have to accept it. Users are not going to want to use, they don't like to use retina scans because the older implementations of retina scans, you'd have to put your eye up on a cup. Well, and then there's privacy issues. So people didn't like retina scans, so they wouldn't accept it. The most acceptable really is the fingerprint scan. People seem to be pretty used to that now. But you have to think about all these things when you're going to use a biometric, even when you use like a hand geometry scanner, which we'll show you what that looks like too. I have to touch it. Right? And people, especially now with COVID and everything, these were all big considerations that we had to work through. There are fully passive controls. A passive control means there's actually no touching that happens. And then the more active controls are ones where you actually touch it. Here's two things about enrollment and throughput. You need to know the difference between these two, terms. The enrollment is how long it takes to enroll with the system. And there's kind of a threshold with what people will sort of accept, right? And it gets smaller and smaller all the time. At the time of this exam, it was 2 minutes or less. Nowadays, everybody's so damn busy. If you ask them to wait 2 minutes to enroll, you might run into some issues. So, but you have to feel it out with your user. Throughput describes how fast it takes. So once I put some sort of authentication to the system, how long will it take for it to process it and give me a return? 6 to 10 seconds is, a pretty good response time in most cases. So things to remember about biometrics: enrollment and throughput. The accuracy. So this is the accuracy. This is where I was talking about before about the false reject, false accept, and crossover errors. The crossover error rate is the actual accuracy of the system. The false reject. So what happens is when you tune, let's say we tune, too many people are getting rejected, right? The false reject rate is through the roof. People are complaining, whatever, so you tune it, right? You tune down the false reject rate, chances are you're going to tune up the false accept rate. So it's finding that happy middle ground between the two and looking for that crossover error rate that's going to be as low as possible, because that's the crossover that's as low as possible. Hopefully that makes sense. But that's how you determine the accuracy of the biometric systems. So false reject rate, this is, it's pretty self-explanatory, but this is where somebody's rejected by the system when they shouldn't have been. So somebody who is legitimately supposed to be using the system got rejected. That only has to happen a certain number before users start getting really mad at you. It's also called the type 1 error. So we have to remember for the exam, they will refer to these different error types as what what their long words are. So knowing that a type 1 error is an FRR, or false reject rate, is going to be testable. False accept rate is the opposite, right? Somebody who's not authorized to use the system can get into the system. From a security perspective, dig that one at all. I would rather users be rejected. Users would rather be accepted. So you'll have this competition sort of between you and the business on these things. Type 2. And here's just, kind of I guess a tip on how to remember the two of those. So I always thought of as far, far is like far. Well, that's also somehow in my mind, I can equate that to longer, higher number. So far to me was always type 2, because I just thought of distance, like far, type 2, whereas type 1 is just the other. So if I remember that far is type 2, I'll know that the false reject rate is type 1, right? And crossover error rate already is, just crossover between the two. So anyway, there's also the sort of the explanation of minutia. So, you take a fingerprint scan, you don't store the image of my fingerprint and then compare the two images. Instead, what you do is you take a mathematical representation, right? Maybe it's the whirls and the swirls and the ridges, and you create a mathematical representation that ideally only my fingerprint would create that number or that minutia. That's what gets stored rather than, because not only is that more efficient, but it's also a big deal if an image of your fingerprint starts, whatever. So the crossover error rate, this is in a type 3 error. There is no such thing as a type 3 error. Type 1 error is your false reject rate. Type 2 error is your false acceptance rate. And then where those two cross is the equal error rate or the crossover error rate. Same thing. That's the overall accuracy of the system. If you tune one, the other one goes the other way. And this is sort of where it looks like. So, yeah, simple. Fingerprints, so different types of biometrics. Fingerprints are the most widely used biometric control. It's also the most accepted biometric control. All kinds of different ways you can implement fingerprint technology, from laptops that have scanners on them to USB scanners of fingerprints to smart cards. Just a lot of different implementations. All you need to do is just give your fingerprint to the screensaver. Now that was the same with the previous version of Apple, had the fingerprint scanner. On the bottom now it's facial recognition. Yeah, you're not going to get probably in any trouble with putting fingerprint scanners in, especially if you can implement fingerprint scanning with single sign-on, so that an executive, all they have to do is just swipe their fingerprint and they don't have to do anything else. They dig that. So you can figure out that equation. That's even better. The minutia I've already mentioned: friction ridges, works ridges, bifurcation, and others. Those are all things that we would derive the minutia and the math for it. Retina scans. People don't like retina scans. These are expensive and rare, really rare to see these. I suppose you could. But the laser scan of the capillaries, so the retina is in the back of the eye. The thing is, with the things in the back, one thing, people don't want to exchange bodily fluid. So a lot of times you'd have a cup and then you'd remove the cup, right? So it'd be like a disposable, the cup piece. Okay? So you'd have the exchange of bodily fluids, including like pink eye and stuff like that would get transferred. But then you also have the retina is telltale signs about pregnancy, about different illnesses. So you could potentially tell if one of your employees was sick with something, and that's never a good thing. So retina scans, not all that common, but they'll be testable. Used rarely, and this is what an older one looks like. So you put your eye up on that thing and let her buck. Iris scan is another one. Iris is more towards the front of the eye. It's where your eye color basically is. It's a passive biometric control, which means you don't have to touch anything. Camera just takes a picture of your eye and then compares it with what it has in the authentication database. It does work with lenses and glasses. They are unique, high accuracy, fast, no exchange of bodily fluids. That's another legitimate type 3 control, or type 3 authentication. It's one of those. That's just a difference between where the iris is and where the retina is, right? The iris on top and the retina on the bottom in terms of those pictures. Hand trees are real popular for a lot of data centers. You'll see a hand geometry scanner. A lot of times you'll use, it's not uncommon to use in physical controls. We talked about that man trap, right? You'd use one authentication method to get into the man trap and use a different authentication method to get on the other side of the man. Hand geometry is almost always in one of those, in data centers and things. Expensive, easy. It just takes basically the math of the thickness and width and all that other good stuff of your hand, and that's what's used for authentication. Fast, not. I would say this is probably more easily bypassed, so it would have a higher false accept rate than maybe a fingerprint scan or a retina scan. But anyway, works. The another thing with hand geometry. Oh, talks if your hand is injured, right? If you've got swelling. I've seen hand geometry scanners not work. Like if you enrolled in the winter when things were colder and your hand was probably a little less, and then you try to authenticate in summer when things get a little more swollen. I've seen that throw these off, so you'd have to re-enroll. I've also seen re-enrollments and weight loss. You've lost a lot of weight or you gained a lot of weight. That might throw it off too. Other biometric controls, keyboard dynamics. This is this is dwell time across the keyboard. This is speed of typing. This is how hard you hit different keys. Those have become pretty, at the beginning, these were really inaccurate. And they've come a long way. So keyboard dynamics is another method of biometric control. Now, it's not exactly what you are, but it's derived from what you are, right? The thought is, the way you type is very unique to you, at least unique enough to where it'd be hard to replicate by an attacker. Dynamic signatures is another way. I sign my name a certain way, certain speed. Pressure points are different. So this is where you just sign on a pad, and based on how you signed, it would authenticate you. Other type, voice print. So this one it's become less vulnerable to replay attacks, but for the test, it's vulnerable to replay attacks. But it's how you talk right now. Sometimes, if I have a cold, I'm hoarse for some reason, that can voice print off. But basically what's going to happen when you do use a voice print is usually the system prompts you to say something, and then you say it back. And that's what's used for authentication. Facial scan is another one. Facial recognition. This has come a super long way. We don't have to get into dead or deepfakes or any of that stuff, but it's come a long way. I would say 94 or 5% accuracy or more, depending on where you used it and what you bought. People used to have privacy things with these, but I don't think they really care anymore because there's cameras everywhere. People have kind of become immune to cameras being everywhere. The funny thing about cameras too, in the United States, we have more cameras per capita than China. Kind of weird when you think about it. China's got a hell of a lot more cameras, but they also have a hell of a lot more people. But scan is a legitimate method of authentication, and it's totally passive, right? You just walk by and it'll take a picture and figure out and do the mapping. Super Bowl 35 was the first major sporting event. And it was actually kind of interesting because, they did catch some people that I don't think they were expecting to catch. And it's a good deterrent, right? People avoid cameras. People avoid cameras and people avoid lights. The bad guys do. They notice that stuff. The normal day people normally don't notice that. And then camera, Apple's iPhone, uses recognition now. These types of biometric controls are all you need to know for the exam. And basically what we covered is all you need to know for the exam. Every one of these biometric controls has some really, really interesting science, and new developments are happening almost every day with biometric controls. It's kind of a fascinating part of security. So if you've got an interest, go there, man. It's some cool stuff. So this is just, a table I think that might help you memorize some of the stuff. So facial recognition is face, fingerprint, hand geometry. Universality is, how common it is in the real world. See, strokes is pretty low, signature is pretty low. Uniqueness, it's how unique the technology essentially is. Permanence, does it change over time? Somewhat, a little bit. Collectability, performance, acceptability. Acceptability is a big one. Face and fingerprint, or face is, definitely the highest, except because people don't typically even know. Fingerprint is a little less because I have to touch a system. But anyway, it's kind of cool. You can do other research on that, right? The thing about multi-factor authentication, everything's hackable. So don't ever think, the goal has never been, it never should be, never will be risk elimination, because it's not possible. What is possible is risk management, and that's what we're shooting for. So having multi-factor authentication certainly reduces risk, but it's not going to eliminate it. I think Roger actually wrote a book about it. So Roger was on our podcast a couple of weeks ago. It's Roger Grimes, super cool guy. 12 ways, and it actually is a lot more than 12 ways. This was old. All right, so transition now for access control technologies. We're way on time. Hopefully not too many questions about what we covered there. The important things to remember are the different types of authentication: type 1, type 2, and type 3. Type 1, something you know. Type 2, something you have. Type 3, something you are. It's really important to know the different types of those authentications. So we talk about, passwords and passphrases and all that stuff. That's all important stuff to remember. Password attacks, I think, are important to remember, whether it be a dictionary attack, whether it be a brute force, whether it be a hybrid attack. That's all important stuff. On the type 2, something you know, that's pretty self-explanatory. I think knowing the difference between synchronous and asynchronous tokens would probably be important for the type 2. And the type 3, certainly knowing the false acceptance rate, which is the type 2, the false reject rate, which is the type 1. Those are errors. And then the crossover error rate, I think, is all important for the accuracy. And maybe just a little bit about the different types of biometrics. Other than that, I think you're good. Right, so transitioning into access control technologies, centralized access control. Thankfully, it's pretty self-explanatory. It's centralized access control, meaning you've got a central access database typically that keeps, identities, keeps authentication material, whether it be hash functions or the synchronous whatever, and also, divvies out permissions typically. So that authentication, authorization, and accountability functions are all kind of in a centralized location. It was funny. It used to be like this like NT, or no, not cool. Whatever, NT, we'll just call it NT. Pre-Windows NT, and then everything kind of blew up, right? You went to this decentralized structure. It's kind of funny how things kind of collapse back down on themselves over time, because now we're sort of focused again back on, centralized access control. Important thing to remember: single sign-on isn't centralized access control. It's just a way to bring decentralized kind of centralized, and then between authentication, authorization, and accountability is going to be important. Decentralized access control. So instead of a centralized access control database, I've got multiple access control databases. They may all synchronize back to a centralized access control, but in function, it's all pushing it out to the perimeter. Really important in more distributed environments where maybe you had a lot of branch offices and things like that. Nowadays, network connectivity is so fast that you don't really need decentralized access control in those environments. Certainly the military using the decentralized access control in battlefield situations, because you may cut off communications, back to, a headquarters or a command and control. So you have to have some decentralized access control there. Important exam warning here, when you see DAC, you have to think about the context in which DAC is being used, DAC. It could be decentralized access control, but it could also be discretionary access control. So I've been told that whenever it's referring to decentralized access control, that will actually spelled out in the exam, but I wouldn't count on it. I would also just take DAC into context. Whether they're talking about, decentralized or centralized access control or discretionary access control, just know the context between the two. Single sign-on is certainly convenient to users. It's actually also, I think easier to manage, more organized. Single sign-on allows sign on once and access, all sorts of multiple. In a true single sign-on, you would sign on once and never have to sign on again, unless you, maybe timed out with the original authentication. But I don't need to authenticate with every server. I don't need to authenticate with every application. It's just log in once and you can access all the things you're supposed to access. That's the point of single sign-on. From an administrative standpoint, it's one database. It's one place where I can provision user accounts. I can deprovision user accounts. I can change certain things on user accounts. So it works, on both sides. This is a good article because it really does point out what the benefits are of of single sign-on. So certainly improved user productivity, a lot less calls to the help desk, because users only have to remember, instead of having to remember maybe 10 or 12 different passwords at work or more, potentially with single sign-on, I could just remember one. People like that. Improved developer productivity. You can write to a single authentication database or mechanism or API, as opposed to having to write your own everywhere. So it does make developers, I think, more productive. Certainly the simplified administration, it's one place to make changes as opposed to, having to go to. It's a pain in the butt. And I know some of you, have done this or have to do this. Try to keep track of all the applications that a user has access to throughout the environment. You might touch, 10, 15 different groups in some complex organizations to just get a user deprovisioned, whereas a single sign-on, you could potentially have to do it one place. It's kind of the nirvana. Disadvantages for single sign-on, they are difficult to retrofit when you have a lot of legacy things. You can script things. You can sometimes, if the benefits for single sign-on are strong enough, maybe it's pushes you to upgrade some of these legacy systems. But implementing single sign-on usually isn't a trivial task, in complex environments. Certainly the attended desktop, if somebody leaves their workstation unlocked, like doctors sometimes do, nurses sometimes do, lots of different places, people leave unattended desktops. An attacker walking by now has access to everything that you had access to across the entire environment, not just a limited number of systems. That's a single point of attack. Right? Single sign-on would be awesome not awesome. You'd attack the single sign-on or the centralized database if you could. So those are the disadvantages and the advantages. I think that's a good summary. The access provisioning lifecycle. So a lifecycle is, from birth to death, right? That's life. So birth, the identity is created, it's provisioned. Well, actually, you'd have to even go probably further than, back further than that. The identities may be created, when they're hired, right? HR enters them into the HR system or whatever the beginning of that life cycle is, all the way till they're gone, right? And gone is probably beyond disabling, right? Gone is like gone, deleted. So how long should they sit in a disabled state before they are actually gone, if ever? Maybe they live on forever. But thinking about all those steps, that's why there's no one single life cycle for every organization. It depends on how you segment it out. It depends on what processes are in place. But it has to account for the very, very beginning and the very, very end, and then all the steps, things that you take in between. That would include, creation of user accounts, provisioning user accounts. It would account for changes in user accounts. So if a user goes to another role within the organization or gets promoted, was it due to their identity or access? All those things have to be taken into account in an access provisioning lifecycle. And there's just one example there of create, enable, exit, and that identity lifecycle. But there isn't just one, right? So here's IBM's description of identity lifecycle, or some of the kind of rules that should be implemented. And I think, again, these are good basic, rules. Password policy, compliance, checking, no users changes the passwords and they expire. Accounts that are inactive for more than 30 consecutive days, something needs to happen, right? In many cases, if you defined it, these user accounts would be disabled. But then you got, usually you get a whole bunch of pushback on these things. Like you have, the Family Medicare Medical Leave Act, FMLA, that will push things kind of sideways or somewhere weird. There are some people who take sabbaticals, extended sabbaticals that maybe exceed 30s. So you always have these exceptions to kind of the rules when you're creating these things. But in general, 30 days of inactivity should lead to some trigger. New accounts that have not been used for more than 10 days, This is really important because, so making these things inactive, because it's not uncommon for somebody to decide not to show up to work the first day and you never hear from them again. So you extend them an offer, they accept the offer, and then you never see them. If you don't have that accounted for in your identity lifecycle, they just sort of live on forever, or they might get triggered on the 30 consecutive day piece. If you've got that implemented, if you don't have that, then it's not uncommon for identities to live on forever in some cases. I'm a big fan of deleting things. So at least when they're disabled, so they can't be used to log in, these identities, but they're still there. All it takes is a simple mistake to re-enable the account. Yeah, I like to delete them. You've got issues, talk with legal, with whoever else has a say in those things. And when contracts expire. So when contracts expire, when, a contractor or a vendor or some other third party that you were using to do certain things, when those accounts when the contract expires, ideally immediately, right? You've set those accounts and having some way to identify those accounts. These are all parts of IBM's lifecycle rules. Problems we run into often with identity or user entitlement and identity lifecycle management is what's called authorization creep. Authorization creep happens when a user account retains privileges or rights or permissions that they had before in a previous role when they moved into their new role. So they just, get more authorization than what they had before. And they don't need them. So the right way to do usually to identity management in the life cycle is to deprovision the account and then reprovision the account. So remove all the access rights from the old role and implement the new one. The challenges with that are business doesn't do things like that as much as they should. There's no cut and dry, right? There's no like, you stop this and you start this. Usually like, well, can she still have a couple of weeks access to this one thing because she's still doing those things for that other group? That's when the authorization creep comes in. If you could make it as cut and dry as it should be, you'd go a long way towards, fighting authorization creep. User rights entitlements, they do need to be routinely reviewed. The challenge here, so this is user rights and entitlements, permissions. Those are a lot different than user accounts. Most organizations struggle enough with user account management, let alone user permissions management, two sort of different things. So first, it's validating that the identity is still a valid identity in the system. If it's not, then disable it. It is still valid. Then the next step would be, does it have the, the proper permissions? This takes a lot of organization. It gets out of hand quickly. But ideally, it would be routinely reviewed. Now, there are tools that you can use, certainly to help you manage these things. But specific tools won't be covered in the exam. Just know that stuff. Federated identity management. So federated identity management is like taking single sign-on, like on steroids. It's taking it to the whole sort of next level. You do it. This is where PKIs come into play because you have this trust amongst probably against different organizations, right? You've got, organization A needs to trust the stuff from organization B to make sure that it actually is organization B. And then those user accounts that might be, shared between those two organizations. So this is cross-organization, inter-organization stuff. So you have to have that kind of third party who will validate that, yes, they are who they say they are. Yes, that's who PKI gives you that. So trusted authority. Another way you could do it is you can use some of these, specific services for federated identity management. I would say, well, Google is certainly a very popular one. You see your Google account used in lots of different places. Facebook accounts use federated identity management, where sometimes you go to a website and you go to create an account and it says, you want to use your Google or your Facebook account. That's a method of federated identity management. SAML, OAuth, there's OAuth 2, OpenID are all examples of federated identity management. Yeah, and they're all used. SAML and OAuth 2 are more common nowadays. OAuth is deprecated, but for the exam, these are all referenceable. Other things with single sign-on identity as a service. Yes, we can make anything as a service. You can make, I should make bacon as a service. That's probably already exists. That'd be cool. But identity as a service, just another as a service, identity as a service, just focusing on identity. So you could have cloud-based applications that maybe call into an API or share information through some secure channel to share that authentication information and that architecture. That's essentially what identity as a service is. Two categories here: web access software for cloud-based applications and web architected applications, which is more backwards compatible. LDAP, we talked a little bit about LDAP, I think a few classes ago. That's lightweight directory access protocol that allows you to access a directory remotely, right? That's what LDAP is used for. Now, I can access that directory, which stores all types of different objects. Some of those objects are user accounts. You can access those user accounts, query those user accounts, and authenticate against those user accounts or service accounts or whatever the objects are through LDAP. Important things about LDAP: default ports, TCP UDP 389, LDAP-S, meaning LDAP over TLS, 636. 3269 might be on the test, but 636 is the one that, if they were going to ask about this on the test, 636 would be the one. All right, Kerberos. This is highly testable. Kerberos is really, really popular. It's all over the place now. So Kerberos is, pay attention to this piece. I'm going to get some of the drink here. Kerberos is that dog that protected Hades' three-headed dog. Kind of interesting. 3 heads: authentication, authorization, and accountability, which we've talked about many times. Kerberos was originally designed by MIT. There still is a version of Kerberos supported by MIT, different than the implementation of Kerberos in Microsoft, which is probably the most widely implemented Kerberos, I guess, install base, mainly for authentication. But the way it provides authentication is it's mutual authentication for one. It's not susceptible to replay attacks. Yeah, and we're going to go through kind of that architecture. Definitely testable. So, this is from MIT. So this is their current implementation of Kerberos, and kind of just some words about why they did it. Now, these particular words, this stuff, there's not going to be anything quoted on the exam. I just thought it was interesting for you to have it. So Kerberos, FAQs, so frequently asked questions, you can go there, but these is what, some of the things that come out of the Kerberos FAQs. We're still talking, by the way, about single sign-on. So Kerberos is a single sign-on authentication technology. Network authentication system used for physically insecure networks. So you can use Kerberos, and it's often used across the internet. Needham and Schroeder is the key distribution model, which we talked maybe a little bit about encryption. I think Brad talked through encryption. But Needham and Schroeder is really a method to share keys across an insecure network. Using essentially public and private keys, public key encryption. Entities communicating with the network prove their identity, prevent eavesdropping. All those things are part of it. Data stream integrity, which prevents from replays, because if I can change the integrity of the data, potentially I could, change timestamps, and replay, things like that. DES is no longer used for Kerberos, but it was back then. So data encryption standard, because it's, weak. Right. Needham Schroeder symmetric key protocol. Well, I just said it was public, didn't I? My bad. Sorry. Symmetric key encryption. If you remember, symmetric, same key to encrypt is the same created key to decrypt. And we're going to get more into this. This is just kind of factual stuff. It's not really all that practical. When you see the data flow, it makes a heck of a lot more sense. Kerberos uses secret key encryption. That means, essentially we're going to use the same key to encrypt and decrypt. That means we already have to be set up somehow with having those keys in each place. Mute authentication for clients and servers, which is really neat because if a new client comes into the environment, it may have all the authentication stuff it needs to communicate with the server, but if the client itself doesn't authenticate, it won't work. Protects against network sniffing and replay attacks. The current version is version 5. There's RFC 41. Remember, RFC's request for comments is it's public domain. So, you can see the full implementation of Kerberos there if you wanted to, way beyond what you need to know for the exam, but certainly there if you want to. This is a page that I would highlight. You'll need to know these different components of Kerberos. The principal is essentially the client, right? Or it could be the service or an application, but it's the client because it'd be a client service anyway. The realm is like a domain, right? It's the area of authority or area of responsibility for the Kerberos network. That's the realm. The TIS is essentially what gets you into places. It's the data that authenticates who you are. Credentials is the ticket and a service key. Now you need to present your authentication to get credentials, but essentially credentials is what's going to get you around everywhere, get you around different servers, different applications. The key DC is kind of the big key. I mean, that's the most important component. It's kind of the centralized component to Kerberos. It's what does the authentication and hands out sort of initial keys, I guess. There's two pieces to the KDC. There's the authentication service itself, which isn't really listed here, but it's an authentication service that does the actual authentication. The second piece is the ticket granting service. So the TGS is actually part of, confusion, but the TGS, the ticket granting service, is actually part of the key distribution center. Two pieces to that key distribution: the authentication service itself and the ticket granting service. And there'll be a diagram here, and we'll show you in a little bit that we'll put that into context for you. The next thing is the ticket granting ticket. That's your ticket. It's going to get you around. And then the client server is just the communications between the two. So this is a really important to know what these things are in Kerberos is going to be really important for the exam. This is what it looks like in a simple diagram. So Sam needs to get a ticket to get tickets. And so he goes to the key distribution center, his communication goes there, he authenticates, and then from the ticket granting service, he gets a ticket granting ticket, right? And then that ticket he can then take on to network services and get authenticated that way. Here's another diagram here. A little more detail here. So if you study this, might be a little bit overkill, but just follow the flow from the principal at domain. The at domain is the realm. So principal at whatever the realm name is, getting that ticket request, the key distribution center, the TGS key is that ticket granting service. And you get what you get back is essentially your ticket granting ticket and your session key. And then you would use that to authenticate with different services and sessions. Even simpler, this is a good one. So the user's authentication server, the authentication server and the ticket granting server are both part of the key distribution center. So it's important to remember that those two in the middle are part of one key distribution center. Yeah, I mean, this is all very, very, I think, relevant to today's network and the way authentication is working. You could go a hell of a lot deeper into all of this, but memorizing, I would say, this slide and this piece and maybe this, those would be the three things I would really focus on for the exam. If you're not managing authentication systems or Kerberos, you don't need to go deeper than that. But certainly if you are a system admin, you probably want to know more. These are ports. These are not testable, but I think it's if you're trying to do, I'd mentioned before, network segmentation and network isolation. When you talk about defense in depth and adversary obstruction, if you remember those discussions, you only allow the ports necessary to communicate across network boundaries. Now, these individual ports aren't going to be testable, but if you wanted to follow the best practice, it's nice to know what these ports are so that you can lock them down. Right? Certainly 543, 544, those. All right, strengths of Kerberos. Certainly the mutual authentication is really key. The only ones who can communicate with system services and integrated applications in a Kerberos realm are those things that are part of the Kerberos realm, right? You have to have this mutual authentication between all the systems. It's nearly impossible to implement a KDC to replace a KDC. That's the key distribution center, right? That's the authentication service and the ticket granting service. Nearly impossible to, implement that because you don't have the keys. And it does mitigate replay attacks because everything is really time stamped. So you can't just capture a bunch of network traffic, try to manipulate a few things, and then send it back on the wire. It wouldn't work. Weaknesses, and these are important. Now, these have all actually in real world have been, not all, most of them have been already remediated. So in practice, the KDC doesn't store plain text keys for all the principals anymore. There are implementations that don't do that. But in general, this will be testable. So the biggest weakness for Kerberos is that the key distribution center does store keys in plain text, right, for all of the principals. That'd be the number one. And definitely testable. I wouldn't be surprised if we saw an exam question about that specifically, even though in practice you can make that not so. The compromise of the KDC does, could potentially lead to the compromise of everything in the entire realm. So that's a really big single point of failure in Kerberos. KDC granting system or service are single points of failure. If they go down, no credentials. Even though it's kind of funky because the TGS is actually part of the KDC, but if they go down with no redundancy, then that's what happens. Replay attacks, I guess, are still, if you've got those timestamps set far enough out, you could do replay attacks still. The biggest one by far on this list of weaknesses is the fact that plain text keys are stored on the KDC. That brings us to Sesame. Sesame came about to fix these weaknesses in Kerberos. Well, actually, the main weakness just being the plain text storage of, in the KDC. Secure PN system for applications in a multi-vendor environment. Knowing that your PN, I think, is probably good enough for Sesame. I don't know if you have to memorize each one of those names. I think your PN is fine. It's a single sign-on system, heterogeneous environment, so it doesn't have to be all Windows, doesn't have to be all Linux. It's different types of systems. Sort of a sequel to Kerberos, but really the reason, the reason why it's kind of thought of that is because it does fix that weakness of storing plain text keys on the KDC. Instead of using tickets, it uses packs, so privilege attribute certificates, and that's actually good enough for what you need to know for Sesame. Sesame is not widely implemented, really, here in the US for sure. But if you want to know more, there's a link there. Testability, these are the things to know about Sesame. Most of the flow is pretty close to the same anyway. All right, now Radius. So these, we're going to go through Radius, we're going to go through TACX, we'll go through TACX Plus, maybe a couple others. So Radius, where it's most commonly used is for remote authentication, but you can use Radius it doesn't have to be remote either. But that's what Radius stands for, remote authentication dialing user service, and it's not really down anymore, but that's kind of where it started. Third-party authentication system, 2 RFCs, so open, essentially open specs on that. Uses UDP 1812 and 1813. There were some other ports that were used prior to that, but 1812 and 1813 are the primary ports today. It is a AAA system, and it really kind of uses almost a proxy kind of setup. This is what it looks like. So remote users access the network access server. The network access server will go back and talk to the authentication or the radius server, which is usually separate. And there's all kinds of things that can be in those messages, right? Usually it's access request and request and accept, but there's also accounting messages that can be exchanged. There's an access challenge, there's status messages that can go on those. But for the most basic, it's the user asks a network access server to authenticate, and then it goes to a radius server to perform that authentication. So that's the most common sort of architecture for radius. Request and response data in radius uses what's called AVPs, or attribute value pairs. And there's an RFC 2865. You can see what those AVPs are. So access request, and then you'll get back from the server either an accept or a reject. And then you'll have accounting request and response. And I already mentioned those. Pretty straightforward. Radius is easy to implement. That's what it looks like, just, with that access challenge piece in the reply message. Now that's the access server. That's not the client, right? So you have a client access server and the radius server. That's another implementation. What it looks like. You could implement a radius proxy that you see over there on the left. Yeah, you could. It's just more complication, really. Yeah. Radius's successor was diameter. So diameter gave you a whole lot more options. So instead of just having, 8 bits for that AVP field, which should, that's essentially things that you can manipulate to do certain, accounting functions and such. Diameter now uses a 32-bit AVP. So, give you a lot more options on how you want to account for what, or track what, or even challenge in the implementation. It is also the AAA framework. So think of diameter as being radius's successor. It just took it kind of to the next level. The architecture is essentially the same. Uses TCP. Remember, radius used UDP, 1812 and 1813. It uses TCP instead, but also an open draft 3588, which has been for the test. 3588 will probably be more referenceable than RFC 6733. So I don't think they've updated the document. I doubt that they'd updated the refresh to include that, but they might have. So they're both there. 3588 was the draft standard. It never actually became a standard. It was replaced by 6733. It was officially ratified. But that's diameter. Don't want to overcomplicate it and go much further than that. Pretty straightforward. Then we have TACX and TACX Plus. TACX Plus, and they're not compatible. They are sort of built off of each other, but TACX Plus, if you're using TACX Plus, you talk to TACX systems. They're different protocols. Terminal access controller, access control system. The first time I think was sent to the design and implementation of TACX. At least that's where I first remember running into it. It's centralized access control. Users send an ID and static password for authentication with the original TACX, which isn't very secure. TACX uses UDP port 49. Could use TCP, and usually use TCP as a fallback. So if there was no response on a UDP call, it would just, after a certain, timeout, it would then fall back to TCP. Not unlike, when we talked about how DNS often works. DNS usually uses UDP port 53 for the initial name resolution, but then if it doesn't get response, it may go to TCP 53. You can configure it that way. Kind of the same sort of thing, right? With TACX, the original UDP 49, and then TCP is a failover. Reusable passwords was a big thing with TACX. So TACX Plus, and there's no multi-factor authentication with TACX. So in order to do that, you needed to have TACX Plus, which was kind of the next step. They didn't care about backwards compatibility. I think it was just another way to, nah. I was gonna say it was another way to get you to upgrade, but there's no way they've done that to make more money. Doesn't make sense. TACX Plus, TCP port 49 for authentication. The authentication is very similar to Radius. You also have options. You have the accounting requests. All that stuff is still there. All the data below the TACX header. TACX header is layer 5, we're going to call it. That's what it looks like. So TACX and Radius, the difference between the two, TACX Plus anyway. TACX is kind of the in between. TACX is not used anymore. Terminal access control system. So you may want to remember that. Functionality separate, triple preferred rather than Radius. Radius, even though you could get Radius, no, you could get Radius to work TCP, but by default UDP and TCP. I think it's a good table there to remember. Right. Geez, password authentication protocol. We did talk about this a little bit, I think last week, maybe. It's not used anymore. Well, I guess it could be used in some places, but it's totally weak. If you do see it, rip it and replace it. It's not a strong authentication method. Send clear text. It's just a simple, here's my username and password, and then the central server, the PAP authentication server, just reply whether that's correct or not. That's all you get. You can see by the RFC number 1334, it's been around for a long time. RFCs continue to increment. So 1334 is pretty old. CHAP came about after PAP, and we did talk this last week. So now remember, RFC 1994, no replay because the challenges change, every time. So the challenge comes from the CHAP authentication server. That's where the challenge comes from. And essentially, there's multiple implementations of CHAP, but oftentimes that challenge is also called a nonce. You remember me saying that, a nonce? So the nonce comes, depending what the routine is, the client would maybe hash the nonce along with their password potentially, and then send that back, knowing that the authentication server already has that, the user's password maybe already stored. It knows what to expect back from the nonce, the password being hashed. That's one implementation of CHAP, but essentially CHAP doesn't send the password over the link. That's we talked about that a little bit. PPPoE is just PPP over Ethernet. So PPP is still PPP. Access control protocols and frameworks, Microsoft Active Directory domains. So those domains, not that unlike really a realm in Kerberos, but a domain is just an area of authority. The systems within that domain are under an authority, maybe whether it be an organization, whether it be a division within an organization, whatever. That domain, somebody's responsible for it. Out of that domain, somebody else is responsible for that one. That's Active Directory in the concept of domains and what those mean. For authentication purposes, Microsoft does use Kerberos and has for quite a long time. Each domain is a separate authentication process and space because it's separate authorities, separate administrative units or administrative authorities. Different users, different network assets and data objects. However, they can also share, and we'll talk about that, the difference between trusts and really basic stuff, right? We don't have to dig deep into trust. These are things to remember about trust, and I highlighted them for you. There's one-way trust and two-way trust, right? One-way trusts are like, I was going to use an example of but I'm not going to go there. A one-way trust is I trust you. You may not trust me. Right? That's a one-way trust. That means if I trust you, that means all the objects and the things, the authentication you send me potentially, I'm just going to take your word for it. I trust you on that stuff. The same way doesn't work the other way. So if somebody authenticates in my domain, you don't trust me, right? That's a one-way trust. A two-way trust is, it's back and forth potentially. Then you've got transitive and non-transitive trust. A non-transitive trust is you trust me and I trust that dude, but that doesn't mean you trust that dude, right? Or whatever guy, whatever domain. So domain A, trust domain B. Domain B, trust domain C. It doesn't mean domain A, trust domain C. Does that make sense? That's a non-transitive trust. The transitive trust means the trust kind of go forth amongst the transitive trust. That's the basics about, how domains, Microsoft Active Domains sort of share information. Without any trust, two separate domains. They don't share any authentication information. If you set trust, then that's how you can share, which then you can kind of bring it to that next level, which becomes sometimes a federation. Yeah, that's the basics of that. Another transition, and then we're almost done. We've only got like 7 slides left, so we're good on time. Access control models. Again, some review here, so that's pretty cool. Just kind of come home a little bit more. 3 primary models we'll talk about here are discretionary access control, mandatory access control, and non-discretionary access control. Mandatory access control and non-discretionary access control are not the same things. They're close, but not the same things. The discretionary access control is the one we're all pretty much used to. A lot of times as security people, we like to think as one is being better than the other. But they're not. I mean, a crappy implementation of one is, still a crappy implementation of one. It's how you use these tools, right? It's how you use these access control models that ultimately dictates, what's best for you. Yeah. So discretionary access control, this is what we're used to, right? You give somebody ownership of a file, a directory, an application, a service. They can then delegate additional responsibilities or change permissions. That's discretionary. It's at their discretion. So given the appropriate level of permissions and rights to an object, the subject can do whatever they want, basically, if they have enough rights to it. So subjects may have full control of the objects. This is really common, right? The sad thing about the commonality of doing this is we do this without defining what the responsibilities are of the subject, who in this case, if you've been given full control of an object, you're essentially the object owner. What is an object owner supposed to do? What are the rules that they're supposed to follow? A lot of times we implement that without thinking that through. But in this case, for what discretionary access control is, subjects, they're little g God over their data or over their potentially other subjects too, I suppose, or different objects. Standard Unix and Windows operating systems use discretionary access control for their file systems, including, probably the Windows domains that we're using now. If a subject does make a mistake, there's loss that often happens. That's why I think it's important, to train subjects on how to handle their new responsibilities. There's no malicious acts, yes, it's more susceptible because it's more open. It's definitely more business friendly. It's more flexible. But even IT admins, give excessive permissions because it makes things work. Subjects do that and sometimes even worse. So implement again, back to which one is best. None of these are best. It's proper planning and implementation that, makes this one the best or potentially a nightmare. Mandatory access control. So this is system enforced access control. The system is set up by an admin, by somebody. You can think of almost like STIG kind of thing, where it's set up as a secure configuration out of the box, and you can't really change it without going through some pretty rigorous steps. So system enforced access control. Subjects clearance, objects labels. That's it. You have appropriate, say top secret clearance, and the data is secret, and that would be a compartmented system. Then you can access the data potentially. You'd also have the need to know, but that's just confusing things. Subjects and objects, clearances and labels, respectively, confidential, secret, top secret. In business, if you were to implement a system like this, which I've never seen it done in private industry, maybe have labels like confidential, internal, and public or something, right? But it's rigorous. It's not very business friendly. It's more government friendly. Subject cannot share objects with other objects who lack proper clearance. There's no write down. There's no delegation whatsoever in a mandatory access control system. Expensive, difficult to implement, rigid. If there's any fluidity to the environment, it's nearly impossible to manage it. Mandatory access control systems that you see there, these are older ones. Honeywell SCOMP is one. Purple Penelope would be another. There is a Linux intrusion detection system that is a hardened version of Linux that is sort of Mac. If you configure it that way. But anyway, that's mandatory access control. Yeah, it's good. Non-discretionary access control is sort of it's not discretionary access control where an owner can be given permissions to delegate and change permissions, and it's not mandatory access control where it's strictly set by subjects clearance and objects labels. It's more based on roles. So usually so this role has all these permissions and access to all these objects regardless of labels and clearance, right? It's the role has all these things and you just plop them into the role. Now they don't get to change. Just because I'm in that role doesn't mean I get to change anything. That's role-based access control. Now, Microsoft, an Active Directory, you can kind of emulate a role-based access control, but it's not a true role-based access control because you do still have these discretionary things in most implementations. So this is not Microsoft, but you could do it in Microsoft. Hopefully that's not confusing. I think if you think non-discretionary access control as being role-based access control, that's fairly close, right? Yes, role-based access control, a type of non-discretionary access control. There's also task-based access control where you're allowed to perform these specific tasks, and that's it. So instead of based on files and information, it's based more on tasks, things you can do. Content and context dependent access control. So content is depending on the content, right? Somewhat sort of like maybe not really mandatory access control. It's more kind of the types of content that you get to access. And a lot of times you'll see this implemented in databases where you can see certain types of content in the database, maybe enforced through views. Views is not on views in a database can be set up to be, content dependent. But, maybe I'm allowed to see people's names and email addresses, but I can't see their driver's license numbers or something like that, right? That would be a content dependent access control. Context dependent is usually based on time. So, users can access the system during these hours and, not on other hours. That would be context dependent. Another context dependent access control is IP address. You can do IP address because it's the context, right? Where are they coming from? What's that context? Yeah. Not full-fledged access control systems, but they'll be testable and they'll probably be on the test. Piece of cake. Security is so damn easy. Can't believe you get paid for this. Just kidding. All right, we made it through class 8. Easy. This is a pretty easy class tonight, but very fundamental. Certainly things to master, even the day-to-day. I think most of the things that we talked about today are very relevant to our day-to-day jobs as well. Certainly, type 1, type 2, type 3, authentication, knowing the differences, multi-factor authentication, knowing password strength and all that good stuff. Yeah, very, very relevant. try to catch up in your reading. You have a night off on Wednesday, so it gives you time. Or if the weather's nice, get out and enjoy it, right? Security's not going anywhere. It's going to be here when you get back. Monday, Ryan will be on for Chapter 7, Security Assessment Testing, which is also very relevant and very good. Ryan and I have made quite a living in doing a lot of security assessment and testing stuff. One more practical, that's it. Have a great evening. We'll see you next Monday. Thanks.